For decades, we've looked to space telescopes like Hubble and James Webb to reveal the universe's hidden beauty. But now, a new eye on Earth has opened, one unlike anything we've ever built. High in the mountains of Chile, NASA has just released the first ever images from the Vera Rubin Telescope, and what they show could transform everything we thought we knew about the cosmos. You've probably seen the breathtaking images from the James Webb Space Telescope, portraits of the cosmos so detailed they feel almost unreal. But here on Earth, a new observatory has just joined that legacy, and the first images it's captured are nothing short of extraordinary. This is the Vera Rubin Observatory, perched atop Cerro Pachón Mountain in Chile, a site so dark and so still, it's often called the gateway to the universe. From here, the thin desert air and clear skies offer a perfect view of the heavens, allowing this new telescope to see deeper and wider than any ground-based observatory in history. At the heart of Rubin's power lies its camera, a colossal machine roughly the size of a small car, weighing over 2,800 kilograms. It's not just the largest camera ever built for astronomy. It's the most advanced digital eye humanity has ever created. Each of its images contains 3.2 billion pixels, so sharp that it would take 385 4K televisions just to display a single frame in full resolution. Every night, this observatory can collect up to 20 terabytes of data, capturing thousands of galaxies, stars, and asteroids in a single sweep of the sky. And thanks to a dedicated high-speed data connection, those images travel from Chile to the United States at nearly the speed of light, where they're stored and analyzed in real time. It's a monumental collaboration funded by the National Science Foundation and the Department of Energy, and operated by the Association of Universities for Research in Astronomy. Unlike Hubble or Webb, this is not a NASA or ESA mission, but NASA scientists are working closely with Rubin's team to calibrate its instruments and process its early observations. And already, those efforts are paying off. In June 2025, the first official images from the Vera Rubin Telescope were released to the world, and what they revealed left astronomers stunned. After just 10 hours of test observations, Rubin had captured millions of stars and galaxies, mapped distant clusters beyond the Virgo supercluster, and even discovered over 2,000 new asteroids, objects that had never been seen before. Among them were several near-Earth asteroids, and while none pose a threat, their discovery proves how powerful this new observatory truly is. But these first images aren't just beautiful. They're a promise, a glimpse of the vast dataset that Rubin will build over the next decade. Each night, it will scan the southern sky again and again, building a living time-lapse of the universe, tracking how stars are born, how galaxies evolve, and how even the faintest objects drift through the darkness. And this is only the beginning, because what Rubin has already revealed is just a fraction of what's coming next. To understand the magnitude of what the Vera Rubin Observatory has achieved, we need to understand the extraordinary machine that makes it possible. Hidden within its dome in the Chilean Andes stands the Simone Survey Telescope, a marvel of engineering designed not just to look at the universe, but to record its evolution in motion. At first glance, it may look like a standard research telescope, but behind its 8.4-meter primary mirror lies something revolutionary. Most observatories rely on a two-mirror system to capture and focus light. Rubin uses three. Its primary mirror gathers faint light from the cosmos. A secondary mirror refines and redirects that light, and then a third, a 5-meter mirror, corrects the distortions caused by curvature, producing one of the sharpest and widest optical fields ever achieved from the ground. This tri-mirror design gives the telescope an exceptionally wide field of view, roughly 10 square degrees of sky in a single image. That's about 40 times the apparent size of the moon. It means Rubin can photograph enormous swaths of the sky in one sweep, capturing millions of galaxies, nebulae, and stars every few seconds. And at the end of this optical pathway sits Rubin's most powerful instrument, the Legacy Survey of Space and Time Camera, or LSST camera. It is the largest digital camera ever built for astronomy, measuring 3 meters long and 1.6 meters wide. Every component was engineered to withstand the freezing temperatures and razor-thin air of the Atacama Desert summit. Inside are 189 individual sensors, each working together to produce the camera's staggering 3.2 billion pixel images. 3 enormous fused silica lenses, one nearly 1.6 meters across, focus and distribute the light evenly across its sensors. A robotic arm places different filters in front of the camera, allowing astronomers to capture ultraviolet, visible, and near-infrared wavelengths. This flexibility lets Rubin observe everything from newborn stars to the faint, distant glow of galaxies billions of light-years away. But it's not just about detail, it's about speed. The telescope can capture an entire image of the southern sky every 3 nights, creating a cosmic time-lapse of unprecedented scale. While past sky surveys like the Sloan Digital Sky Survey took over 20 years to map 1/3 of the sky, Rubin will map half the visible sky every few days, again and again for 10 straight years. This constant repetition will allow scientists to detect movement and change, from exploding supernovae to colliding galaxies to near-Earth asteroids drifting silently through our system. Even the smallest flicker or shift in brightness can be caught, recorded, and analyzed. In a way, Rubin doesn't just take pictures, it watches the universe breathe. Every night, it will send up to 20 terabytes of new data through a high-speed connection directly to the United States, where supercomputers in California and Illinois will begin processing it instantly. Over the course of the survey, that stream of information will grow into one of the largest datasets in human history, over 500 petabytes of raw data, cataloging billions of objects and trillions of individual measurements. The result will be a living map of the cosmos, one that doesn't just show us where things are, but how they move, evolve, and disappear. And the first test images already prove that Rubin's precision isn't just theoretical. In only a few hours, it captured structures, galaxies, and asteroids that no other observatory had ever seen before. It's a glimpse into a new era of astronomy, one where we no longer just observe the universe. We follow it in real time. In June 2025, the wait was finally over. NASA and the Rubin Observatory released the first official images captured by this groundbreaking telescope, and they were nothing short of breathtaking. After just 10 hours of test observations, the Vera Rubin Telescope had already done what used to take other observatories decades. It revealed millions of stars and galaxies, thousands of previously unseen asteroids, and entire clusters of cosmic structures stretching deep into the Virgo constellation. One of the first mosaics, titled the Cosmic Treasure Chest, became an instant icon among astronomers. It's a massive 25 square degree image composed of over 1,100 exposures, each layer revealing more hidden detail than the last. At its center lies a section of the Virgo cluster, about 55 million light-years away, the closest large cluster of galaxies to our own. In the image, 2 enormous spiral galaxies dominate the upper left, their glowing arms stretching across space like tidal waves of light. Between them, 3 smaller galaxies appear locked in a cosmic dance, their shapes distorted by gravity and time. Everywhere you look, the scene teems with life. Threads of material connect galaxies like veins, while tiny points of light in the distance represent galaxies even farther away, each containing billions of stars of its own. Astronomers call it a universe within a single frame. And remember, this image covers only a fraction of what Rubin can see in one scan. Another image, no less impressive, focuses on a familiar sight, the Lagoon Nebula, but never like this. Composed of hundreds of exposures over 7 hours, the Rubin image shows the nebula as a vast pink and blue expanse, stretching 55 light-years across and glowing with regions of star formation. Near its center, young suns are still being born from swirling clouds of dust and gas. Compared to the narrow, high-detail close-ups of Hubble, Rubin's image feels panoramic, a grand view that captures the nebula, nearby clusters, and even distant galaxies, all in a single unified scene. It's a reminder that the universe is not made of isolated wonders, but of interwoven stories written in light. And these are just the first glimpses. In time, Rubin's images will expand into a moving portrait of the entire southern sky, a living atlas that grows, shifts, and evolves night after night. In just a handful of hours, the Vera Rubin Telescope accomplished something extraordinary. It didn't just take pretty pictures, it began rewriting our understanding of the universe. During its very first night of operation, Rubin detected 2,104 new asteroids in our solar system, objects that had never been seen before. Some were drifting silently in the asteroid belt between Mars and Jupiter. Others were far closer, 7 near-Earth asteroids, small worlds quietly passing through our cosmic neighborhood. And while none pose a danger to Earth, their discovery sent a clear message. Rubin isn't just looking at the distant universe, it's protecting our own. To put that in perspective, all other ground and space-based observatories combined discover about 20,000 new asteroids per year. Rubin, operating for just one night, identified more than 10% of that total. At this rate, astronomers estimate that within its first 2 years of operation, Rubin could discover millions of new asteroids, creating the most comprehensive catalog of small bodies in solar system history. But it doesn't stop there. The telescope also identified 46 RR Lyrae stars, ancient pulsating beacons that act like cosmic mile markers. These stars rhythmically brighten and dim, and by measuring those pulses, scientists can determine how far away they are. With Rubin's precision, we'll be able to use these stars to map the outskirts of the Milky Way and even trace its faint stellar streams stretching more than 1 million light-years from Earth. By the end of the survey, Rubin is expected to detect over 100,000 of these pulsating stars, allowing astronomers to reconstruct the true shape and size of our galaxy. The telescope's power also opens the door to one of astronomy's newest frontiers, the hunt for interstellar visitors. Objects like Oumuamua and 2I Borisov passed through our solar system in recent years, each one an enigma from another star system. Until now, we've only been able to catch such visitors by chance. But Rubin changes that. Its nightly scans, covering half the southern sky every 3 days, make it uniquely capable of spotting fast-moving interstellar bodies as they approach, days or even weeks before they pass through our neighborhood. For the first time in human history, we might detect an object from another star system in real time and observe it before it vanishes into the dark. And then there's the scale of data. Rubin is unlike any observatory before it. Every single night, it collects up to 20 terabytes of raw information, tracking millions of stars, galaxies, and asteroids, all in a single session. Over the telescope's 10-year mission, that number will rise to 500 petabytes of data, 500,000 terabytes of the universe, stored as a living, breathing record of the sky. It will be the largest astronomical dataset ever created, a goldmine for scientists, engineers, and AI systems alike. But perhaps the most revolutionary aspect of Rubin's mission is not just what it captures, it's how often. Where past surveys like Sloan took 2 decades to build a still image of the cosmos, Rubin will create a time-lapse of the entire southern sky, a movie of the universe unfolding before our eyes. It will catch every variable star, every transient supernova, every fleeting flare that lights up the night, and record how they change from day to day. This constant watchfulness transforms astronomy into something new, not a static science of snapshots, but a living chronicle of cosmic evolution. For researchers, Rubin isn't just a telescope, it's a cosmic time machine, one that will let us witness the birth and death of stars, the collision of galaxies, and the slow dance of celestial bodies that shape our universe. And yet, for all its scientific precision, there's something deeply human about the Vera Rubin Telescope. It carries the name of a woman who defied convention and redefined physics, Dr. Vera C. Rubin, whose groundbreaking work first confirmed the existence of dark matter. Her discoveries reshaped our understanding of reality itself, and now her legacy is looking farther than ever before. As Rubin's gaze sweeps across the night sky, it's not just collecting data. It's extending her vision, illuminating the invisible, capturing the unknown, and reminding us that discovery never ends. And what we've seen so far is only the beginning. As breathtaking as these first images are, they represent only the opening frame of a story still unfolding. The Vera Rubin Telescope has barely begun its decade-long survey, yet even in its earliest hours, it has proven itself to be one of the most powerful scientific instruments ever built. When the observatory reaches full operation later this year, it will scan the southern sky every few nights, capturing billions of stars and galaxies, each one recorded in extraordinary detail, again and again. With every pass, it will note what changes, what brightens, what vanishes. In doing so, Rubin will create something no telescope ever has before, a living chronicle of the universe. A decade-long time-lapse revealing the constant motion of the cosmos. Imagine watching the universe breathe in slow motion, nebulae expanding like smoke, dying stars collapsing in bursts of light, galaxies colliding and merging over time. For the first time, we'll be able to see the sky not as a still image, but as a dynamic ecosystem, alive, evolving, and infinitely complex. The implications go far beyond beauty. This telescope will deepen our search for dark matter and dark energy, the invisible forces that shape everything we see. It will map how galaxies cluster and drift, how the expansion of the universe accelerates, and perhaps how the story of creation itself continues to unfold. For planetary scientists, Rubin is equally transformative. It will spot thousands of new comets, near-Earth asteroids, and trans-Neptunian objects, helping us understand the history and architecture of our solar system. It may even be the telescope that detects the next interstellar visitor, the next Oumuamua, before it slips past us forever. But behind the numbers and discoveries, there's a deeper message written in light. Dr. Vera C. Rubin once said, "Science progresses best when observations force us to alter our preconceptions, She spent her life revealing the unseen, the hidden matter that binds galaxies together. Now, the telescope bearing her name is continuing that legacy, peering into the cosmic shadows she first helped illuminate. Every image Rubin captures, every faint galaxy or subtle flicker of a star, is a continuation of her work, a reminder that progress comes from curiosity, and that curiosity never truly ends. And this is only the beginning. The Rubin Observatory will produce over 500 petabytes of data, a digital treasure trove that will take decades to explore. It will inspire discoveries not just from scientists, but from anyone with the passion to look deeper, because its data will be open to the world. Students, dreamers, and amateur astronomers will have access to the same universe as NASA's finest minds. For the first time, discovery belongs to all of us. So the next time you look up at the night sky, remember that somewhere, high in the Chilean Andes, a telescope is watching too, scanning the same stars, recording the same moments, capturing the same fleeting beauty we see from Earth. Only now, it's immortalizing them. The first images from the Vera Rubin Telescope are not just pictures of the cosmos. They are glimpses of our future as explorers of the infinite, because every great journey begins with seeing. And now, for the first time, we're seeing the universe in motion. If this filled you with wonder, make sure to like this video, subscribe to Stellar Path, and turn on notifications, because what comes next will redefine how we see the night sky. The next images are already being processed, and what they reveal could change everything.